Okay. So remember, we have been talking about parabolas, which are second-degree polynomials. They're also called quadratics, yes? We have learned to factor them. We've learned there's special cases by factoring by grouping. Sometimes they're perfect squares. And if they do factor and you graph them, the factors, when set to equal to 0, called the roots. Sometimes you can't see where the roots are exactly because they're irrational, but they might cross. So anytime it crosses or touches the x-axis, you have some sort of root. Okay? Then there is a way to start going through these when you can start graphing them, and they're set up in something called vertex form. What do you think vertex form kind of points to? Vertex, yeah, you find the vertex. And then we also learned about the pattern graphing, right? The pattern graphing worked going 1, 3, 5, or negative 1, 3, 5, or your a value, which is your very first value attached to the x squared term, times your 1, 3, 5. So you could pattern graph off of that as well. Remember all that? Hey, notes are ready. All right, let's see. She there, you there. Cool. There you go. All right, so we are looking on that first page. And I have on that first page, I have 3 graphs. I have y equals x squared. I also have y equals x squared plus 3. And then I also have y equals x squared minus 2. Everyone see that on your first page? On page 91? Okay, so let's take a look at what these graphs are going to look like. It looks to be the very first one, we're missing the b term and the c term. Agree? So really, if I were to find the vertex of this, here's my vertex. I can pattern graph right, using the 1, 3, 5 because my lead coefficient's 1. So I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, so on and so forth. Now, if you want to see what the patterns start doing up here, if you want to start seeing the patterns on any type of graph, is you have to find like a critical point. So your critical point here is your vertex, and it appears that our vertex is 0, 0. Agreed? So, next thing we're going to look at is, do I have anything in parentheses on here? No. If you have something in parentheses, that means it's going to shift to the left or to the right. If you don't, it means it's going to shift up or down. Just by knowing that little bit of knowledge, would you think this would shift up or shift down? Up. So our vertex is here. Can I still pattern graph with the 1, 3, 5? Yeah, my a value is still 1, so my 1, 3, 5 is going to work fine. So right 1 up 1, left 1.
Are these new, or is this what we were doing last time?
Well, I didn't teach you vertex form, but the pattern graphing is still the same, right?
Okay.
So that's what that one does. So will you kind of describe to me what's the difference between the black parabola and the blue parabola? Go ahead, Jake.
It has a number for the y-axis.
Okay, has a number on the y-axis. That's not 0. Yeah? The blue one doesn't touch the x-axis. Could we say there is a shift from the black to the blue? And if so, what kind of shift do you think took place? Yeah, upward. So if we add a number to it, it'll shift up. What do you think the green parabola is going to do with it? We don't have a graph yet, but shift down. How many? 2. So the black is known as the parent function. That's the most basic parabola you can have. But this one shifts down 2. So I got 1, 2. I'm going to go right 1 up 1. Left 1 up 1. So the pattern graph still works. Right 1 up 3. Left 1 up 3. And this green parabola just shifted down 2. So if we add and it's not bound by parentheses, if we add something not bound by parentheses, that means it's going to shift up. The vertex will shift up that much. The pattern graphing is still going to work the same way if you look at your A value. If you subtract and you're not having any parentheses, it's going to shift down. So we're on our way to talk about what this equation is. Y equals A, parentheses, x minus h, quantity squared plus k. Don't let the letters confuse you. H and k are just different x and y values. Okay, but they use h and k. Why do they use h and k? I don't know. I wasn't at the meeting. Okay, so right now, all of these dealt with a k value. Hey, what's the k value of this top one, would you think? 0, yeah. I could put a plus 0, and that's my k value. Of course, it works better when I... Come on, baby. Plus 0. So there's my k value there. So my k value is either added or subtracted outside of it. When I say, is there inside parentheses, you have a grouping of parentheses. So that's our first thing. That's our first thing. How do we feel? So a parabola can shift up or down. We know that because we've already graphed plenty of these and we've not had them all start at 0, 0, correct? Can I move to another slide? Okay. So the k value affects it moving up or down. So if you got a packet from me, you need to look down at the very bottom and go to page 92. They're out of order. I'm sorry, it's Monday after break. I goofed. But if you have your actual book, turn it to page 92, please.
On the first one would be able to use a calculator.
There you go. All right, so let's start this next one where we have y equals x squared. Sneeze coming. Thank you. Green one. See how fun this game is that I'm playing. You guys are all now on your phones looking for this app going, dude, I want to play that game. Huh? Okay. And again, we're working off of this. Y equals A x minus h quantity squared plus k. So what value do you think we're working with on this equation now? We already worked with the k. Which one is it here we're going to work with now?
H.
H. Okay? You can identify h. And the nice thing is this type of shifting that we're showing you both with the k shifting up and down and now with the h is the same kind of shifting that takes place with all math, with all graphs, which is kind of cool. So the very first one, this is our parent function. This is our most basic parabola. Okay. What would you feel that our h value would be on this parabola? 0, okay? We'll get to that in a second. All right, so let's take a look at this green one. Now, crazy little thing that takes place in math is if you group something, it will shift the opposite way you think it should. So by looking at that green one, would you think it would shift right or left by just if you looked at it first thing right now? It seems right because it's positive, correct? Unfortunately, in math, if it's grouped, like in parentheses, it's going to shift the opposite way. So which way should this green go if it goes with my language? It goes left. So our vertex is going to shift left 3. So 1, 2, 3. Pattern graph still works the same, right? 1, left 1, up 1, 2, 3, left. So using your verbiage, the black to the green, what kind of shift took place? Did it shift up or down? Shifted what?
Left.
Shifted left. Now, if the plus shifted it left, what do you think the minus is going to do to the red? Shift it right. So again, anytime it's grouped, it's just going to shift the opposite direction you think. Okay, so that's going to be 2. 2, right there. Still pattern graph, same. So does everyone feel comfortable saying that the red one shifts to the right from the parent function, which is y equals x squared? Yeah? Yeah.
Does this only apply to parentheses equation?
If it's inside parentheses, it's going to shift either right or left, and it's always opposite of your thought process.
So what if like there's an equation inside of this one?
Oh, yeah, baby, we're going to get there right now. Good question. Yeah.
The square, like the fact that it's square doesn't mean anything.
Nope, it just means you have a quantity squared, which means if you factor out that part, it becomes a perfect square trinomial. So a perfect square trinomial like that we would have factored, just an example would be like y equals x squared plus 6x plus 9. So that would break down to x plus 3, and x plus 3 grouped together as x plus 3 quantity squared. That's where this is coming from. Yeah.
So when you did the graphing, you figured out what x was, and that's where it was doing.
Okay, so this is the h value. This is shifting the h. So this one, if I wanted to rewrite it, would be, that tells you it's not shifting either way, right or left. I could have a minus there as well. It's 0. It doesn't really matter. Okay? So the h value shifts it left or right. The k value shifts it up or down. And the last thing we're going to do is we're going to start changing the lead coefficient a value. Let's see if this is going to work this time. Okay, here, open up, close that, open here, go here. So I have y equals x squared, parent function, right? It's the most basic parabola. Negative 2x squared. Okay? That's kind of our a value. So if I go back to my general equation, y equals a x minus h quantity squared plus k. Do I have an h and or a k value on any of those right now, other than 0? Does everyone feel comfortable if I said that? Jasper, you're stretching. Okay. So there's not an h or a k value on there, so they have to be 0. So these are not going to shift right or left. So let's draw our parent function. Okay, parent function looks the same as all the others, I hope. It is Monday, though. What do you think this 3 is going to do? Go up how? I'm going to tell you that the vertex is still going to be right here. Yeah.
It's going to multiply the, I forget what it's called, but it's going to make it.
I'm with you. The 135, correct? Yeah, it changes the 1, 3, 5 in this case because there's a 3. So this isn't going to be, this one graphed as 1, 3, 5, but this one's going to graph as 3, 9, 15, right? And this is obviously going to grow way faster that we won't be able to do it. So let's take a look. So I'm going to go right one up 3, left one up 3. Well, I don't know if I can get to the next one. Right one up 9. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's up here like that. 9. Yeah.
So technically, whatever number is in front of the x is multiplied by 1 through 5. So if it was 6, it would be 6, 18, 30.
Got it. Good job. So this is something called a vertical stretch. Does that kind of language make sense? Vertical stretch? It's like a rubber band. We're stretching it. You stretch a rubber band this way, it gets skinnier. Correct? So this is a vertical stretch. If you wanted to put the actual math lingo to it, you don't have to know this, but this has a vertical stretch of a component of 3. Gosh, where did the 3 come from? Ah, the A value.
Will we ever have to know that in math?
I'm just, eventually.
Yeah.
Not this week, though.
Yeah.
Not next week, not the week after.
Yeah, just like
Not even by the end of May. Hey, what's going to happen with the blue? It's going to go down. Does everyone get that?
Yeah, it's negative.
Yeah. So my vertex is still here. It's not going to be 1, 3, 5. It's going to be what? Negative 10. Good. So from my vertex, which is 0, 0, because we don't have an HK value,
1, negative 2.
I'm going to go down 2, 2, and then I go down, how many? 6? 1, 2, 3, 4, 5, 6. This way down 6. Blessing you. So this has a vertical stretch, which is twice as much. But then it also has a flip over the x-axis because the negative. That's it. Give you a booster chair. Hey, how are we feeling? Are we ready to make up our rule? So here's my rule. Ready? My vertex will be at h, comma, k. Notice something up there. What's the general rule for h? What's the sign in front of h? What's the sign in front of h? What's the sign? Not the variable. Negative. What is the sign on the vertex for h down here, though?
Oh, I get it.
It's doing the opposite. What's the sign before my k? Positive. What's the sign before my k on my vertex? So do you see how this sign is the same right there? But this sign does a magical change. Change. So if this was a plus, that's a minus. If that's a minus, that stays a minus. So the sign outside stays the same. The sign inside that's grouped will change. And guys and girls, this is the same for every type of graph in math. It's not just parabolas. When you get to the ones that are raised to the third power, the fourth power, if you put sine, cosine, or tangent, and that's sin, cos, tan, those are the buttons on your calculator. You put that in, same rules apply. It's so cool that these rules actually kind of make sense. It's not like this, well, this week it's going to be this way, but next week, forget about it. No, it works every time. The equation itself might change a little. This exponent might change a little, but the shifting itself does the same. The A value causes our graph to stretch. Okay? It could compress it. if you had some fraction. Okay, if you had like 1/3 there, something like that. But for the most part, if that says fraction, my writing's horrible. I haven't held a pencil all week. So that's the general rule. All right, so I would like us. I have the second sheet, and it's just still notes, and we're going to go through them. There's 4 graphs. We're going to go through them. You're going to talk me through it. It does. Good job. Totally does. I had to think about it for a second. Wait a minute.
Yeah, because that's why it stays the same, right?
Yeah, because the k value will be the y component of the vertex. The y component of the vertex, or excuse me, the x component of the vertex is always the axis of symmetry. Awesome. Good for you putting that together. All right, ladies and gentlemen, let's go to the problem on here. That is, find this problem. Okay, so I want you to start thinking about, first thing I want you to label on here is see if you can identify what the vertex is. While you're doing that, I'm going to bring up my grid so we can... What do you think the vertex is on this one? Negative 2 and negative 3. So negative 2, negative. So notice that sign flips. That one stays the same. Will this pattern graph as 1, 3, 5?
Yeah.
Yep, because I don't have anything out in front. Okay, so negative 2, 1, 2, down 3. 1, 2, 3. Is that right? Do I do that right? My numbers are off a smidge. My numbers are off a smidge because I got 1, we got 2, we got 3. Okay? Pattern graph will work. It's going to open up because there's not a negative out front. So I'm going to go right 1 up 1, left 1 up 1, right 1 up 3, left 1 up 3, right 1 up 5, left 1 up 5. Logically, does that make sense? That's a negative 2 and a negative 3. On the graph, I'm going to pull up, I'm going to make a change to this grid. My numbering is off on that. The boxes are correct. It's when they got the numbers. So I'm going to try and let me find one that doesn't have those numbers in there. So we'll Google and Google.
XY axis. Images.
I like that. I like that one. That's a good one right there. I'll keep that one. That's a keeper. Images. better? Alright. That looks a little better. It's a little blurry, but we don't judge. Alright. Ready? Second problem. I have y equals quantity x minus 4 squared plus 1. So first thing I want us to identify is let's identify the vertex. What do you think? Positive 4, comma, positive 1. I like it. Everyone feel comfortable with that? So it's going to be positive 4, positive 1. No, I don't have to keep the positives there, but I just put them in there just so you saw. Realize what happens there, realize what happens there. So if I plot 4, comma 1, I got 1, 2, 3, 4, up 1. Agree? Hey, if I pattern graph with 1, 3, 5, does this open up? And can I use 1, 3, 5?
Yes.
I can, and it opens up. If it opens up, guess what? It's not going to cross the x-axis. So right, 1, 1, 2, 3. So that's it. So when it's in something called vertex form, you can identify the vertex. The nice thing about the vertex is it becomes a point that you can start tracking easily. Okay, there's infinite points up here, but there's only one point up there that goes from it going down to going up, called the vertex, or it's the lowest point or the highest point. We okay so far? All right, I'm going to go to the back side of that page. Some of you might be still stuck there. Let's paste.
Yes.
Paste.
This one's gonna be changed.
It's going to be, yeah. What do you think? What's happening?
You gotta do the multiplication.
Yeah. Oh, yeah. You saw that -2 out front, huh? Okay. Question for you. Where does it appear the vertex is going to lie? Ignore the -2 right now. Where does the vertex look? Go ahead. -3, positive 4. So look at that. Look at that. -3 and positive 4. Agree? Okay, so I get -3, 1, 2, 3, positive 4. There's my vertex. We can definitely identify that this had shifted left 3 and up 4. Now, what does that -2 out front do? So it's not going to graph as 1, 3, 5. It's going to graph as what?
2.
Almost -2.
-6.
Does that make sense? So this is opening downwards, right? All right, so I'm going to go right 1 down 2, left 1 down 2, right 1 down 6, left 1 down 6, and then down 10 is going to be way too far. Yeah.
Why wouldn't we distribute the -2?
Well, order of operations would say you'd have to do the exponent first, so you'd have to go x plus 3, FOIL that out, then distribute the 2 over, and then add the 4 to the constant. Yeah, because you have the 1, 3, 5 rule, because that's a negative. Are we ready for the very last one? Yay!
So is everyone just going to be graphed?
Yeah. Okay, it doesn't like you either. All right. What's that last part? Ooh. Okay. This is okay. I think we can do it.
You just flip everything from -1 to -5.
Yep. Okay, so quick question. Which letter are we missing up there?
Okay.
Good. We're We're missing k. If k is gone, it has to be what?
0.
It has to be a 0. Okay, so we're missing that k value. It's actually 0. Okay, so what's my vertex, do you think? Negative 2, comma?
0.
Cool. So negative 2, comma 0.
Down.
You're right. Come on. Well, wait, what happened? I didn't even sneeze yet. Is that the one we're on? Okay. So, we want the 1, 3, 5. And Brandon pointed out it's going to be negative 1, 3, 5. Is somebody messing with this thing? I tell you, this thing's goofy.
Oh my god, it's a bug.
Woo!
We're being haunted.
All right, everyone good with the negatives there? All right, so I'm going to go right 1 down 1, left 1 down 1, right 1 down 3, left 1 down 3, and we could squeeze the 5, but it's not really necessary. There it is. That's it. That's all we have. Okay? So, your assignment is just going to be graphing. Sketch the graph of each function. So you'll find the vertex and pattern graph. That's all we're doing. There's a front and a back to this. Looks like 8 full problems, which you have a few minutes to get a start on it. I don't think it's the worst thing out there. This will be checked off tomorrow for points. So make sure you try all of it so you can get a top mark. When you come in and you don't have anything, that kind of makes it hard. Especially because you didn't build on.
Wait, so 95
Nope, this page. That's right here.
oh.
I didn't have a page in the book for you, so we had to make one. Okay, so this GQF number 8 that does not come out of your workbook. This is what homework is for tomorrow. Okay?
This one's for tonight.
Yep, that's it. There's front and back to it. I think you guys and girls could probably get at least one done before we